In this video, we're going to create a set data structure in C, as well as a collection of functions to work with the set data structure, including common set operations like union and intersection. So first we'll go over the basics of sets, and then we'll go over how to implement these in C. So a set is a collection of items. So for example, the set containing the items 492. We usually use these squiggly brackets to represent a set. Now we can have an empty set with no elements, like this, and the order of the elements in a set doesn't matter. So we could have 492 and the set 924, and these would be equal sets. They would be the same set. The number of occurrences of an element in the set doesn't matter. So if we have 44492, this would be equal to 492. As a result, we're only going to store the unique elements of a set, because duplicates just don't really matter. We can insert elements into a set. So for example, we could insert 4 into the set with 29, and it would give us the set with 429. We can perform a set union. So if we had a set with the elements 1, 2, 3, and we did a union with the set with the elements 2, 3, 4, the resulting set would have the elements 1, 2, 3, 4 in it. And we would call this the union of these two sets. We can also have a set intersection. So if we had a set with the elements 1, 2, 3, and a set with the elements 2, 3, 4, the intersection of those sets would be the set with the elements 2 and 3. So the intersection of sets contains all the elements of one set that are also in the other set. There's also the set difference operator. So if we have a set with the elements 1, 2, 3, and we subtract the set with the elements 2, 3, 4, we're going to be left with the set with the element 1 in it. And that's because the difference of the sets contains all the elements of the first set that are not also in the second set. So in this case here, 2 and 3 are also in this second set here. So that's why we're left with just 1 in the resulting set. There's also the idea of a subset. So here, the set with the elements 1 and 2 is a subset of the set with the elements 1, 2, and 3. Because a set A is a subset of set B if all the elements of A are also elements of B. So that's really it in terms of the basic set operations. Now what we can do is implement these in C. Now I should also mention that sets aren't limited to containing only integers. Sets can contain letters, words, objects, really anything. A set is a very abstract concept in mathematics. As in the examples below, our sets are going to contain integers. We're going to be creating what's called a data structure. And a data structure is really just some way of organizing information in a computer. And we're going to be creating a set data structure that's really focused on learning about how data structures work. If we were going to create a set data structure to be high performance, we would do things a bit differently and we would use some more advanced techniques. So this tutorial is more about learning how data structures work and how we can create them and work with them in C, more than about creating a high performance set data structure. So the first thing we'll do is use typedef and struct to define a new type for our program to use. So we'll say typedef struct set, and our struct is going to have two members. We'll say int star members and int length. So length is going to be the number of members in our set. And this members, this pointer to an int, it's going to be a pointer to a dynamically allocated array that's going to contain the members of our set. So we're going to be sort of using an array as an underlying data structure to help us implement and work with sets. But we're going to be ensuring that when we implement the operations for our sets, that they actually behave in the way that sets should behave. So the first thing we're going to need is a function that can create a set struct for us. So we'll say here set star init. And this function is going to be initializing a set for us. And we'll copy and paste this. And down here, we'll define the function. And this function is basically going to return a new empty set for us. It's going to initialize a set. So we'll say set pointer new set is equal to malloc size of set. So malloc is going to dynamically allocate memory on the heap for something the size of a set. And then this set pointer here, new set, is going to point to that thing. We're going to be using the heap and dynamic memory allocation because a lot of our operations involve creating new sets or inserting elements into a set and expanding the number of elements that a set contains, all of which are far better handled using the heap. So we'll set the length of this set to 0, because initially we're going to say that our sets contain 0 elements. They're an empty set initially. We'll dynamically allocate space for a single int value for our members. So we'll say new set members is equal to malloc size of int. So we've allocated enough space for one integer in our members dynamically allocated array there. And then we'll return new set. So we're going to return a pointer to this new set struct that we've created. So now we can create a set. So here I'll say set star set A is equal to init. And technically what we've got at this point is a pointer set A that points to a set that's been created on the heap. So next we can start to implement operations to work with sets. So for example, maybe a function that determines whether a set is empty or not. Right now this set with no members in it would be considered empty. So we're going to include the stdbool.h library just so we can use the bool type and return things like true and false. And we'll make a function bool is empty set star set. And this function is going to return true if the set is empty and false otherwise. And we'll define it down here. And it's going to be a pretty simple function. We're going to return true if the set length is equal to 0 and false otherwise. So we're just going to return is the set length equal to 0 or not. So we could actually test this out with our set A here. We could say if is empty set A printf set A is empty. Otherwise, printf set A is not empty. So we can save this, run it, and we can test out our first function now. And we should get that set A is empty. Oh, we got build failed. What did I do here? Oh, you know what I forgot to include was the stdlib.h library. We need to include the stdlib library if we want to use malloc. So here I'll say number include stdlib.h. So we'll save it and run it. And we get that set A is empty. So that's our first function there. Now the next thing we might want to do is implement a function that allows us to insert elements into the set. So here we'll say void insert set star set int member. And this function is going to insert the integer provided by this argument into this set. So we'll provide a definition of the function down here. And this function is actually going to be somewhat complicated because remember, sets have this very special property that we don't really care about repeated elements. We really only care about storing the unique elements of a set because a set with 4 in it twice is the same as a set with 4 in it once, assuming all the other elements in the sets are the same. So the first thing we'll do is check to see whether the element is in the set or not already. So here we'll say bool in set is equal to false. And we'll loop through the elements of the set, checking to see if this member is in the set already. So we'll say for int I is equal to 0, I is less than the set length, I++, and if the set member at index I is equal to this value that we're looking for, then we're going to set in set equal to true because we found this element here in our set at the index I. And if the element is not in the set, we want to insert it. If it is in the set, we don't have to do anything because it's already in the set. We can just leave it alone. So if the element is not in the set, then at this point, we want to insert the element into the set. So inserting the element into the set is actually going to be a little bit tricky, because what we have for our members member of this struct here is a dynamically allocated array. And initially, we've just allocated a space for one integer. But as we add more elements, we're going to need more space. And that's where we're going to use realloc. So realloc is going to allocate more space for us. And it'll save whatever's in the existing members dynamically allocated array when more space is allocated, but it will go out and dynamically allocate more space for us. So we'll say here, set members is equal to, and we'll call realloc. We'll say realloc set members is the first argument, which is the thing we want to reallocate space for on the heap. And then we'll say size of int times the set length plus 1. And what we're doing here is we're going out and getting enough space on the heap to store however many integers we've got in our new lengthened set, because we're adding 1 to whatever the length of the set was previously, because we're inserting this new member now. And so we're going out and allocating enough space for that many integers, 1 more than the current length. So next what we'll do is set the actual member as an element of our members array. So we'll say set members, and we'll say set length is equal to member. And we're adding this member, this new member here, to our set members array that's keeping track of what's in our set. And we're going to add it at the index set length, because that's going to be the next available index. And then finally, we're going to increase the length of our set by 1. So we'll say set length is equal to set length plus 1, and we'll increase the length of our set by 1 as well. So now we should be able to insert members into our set. So up here in our main function now, I could call the insert function. I could say like insert set A 5, insert set A, and I'll say 6, and insert, we'll have set A and 7. And this should insert those 3 elements into our set. Now, unfortunately, right now, I can't really see our set. I have no way of printing it. So that should probably be the next operation we implement, is some way of printing our set. So here I'll say void print set, and we'll make a print set function to print out our set. So we'll copy and paste this down here. And to print our set, we're basically just going to loop over the array of members of our set, and we'll print out each one of them. So we'll say here for int I is equal to 0. I is less than the length of the set, I plus plus. And we'll say if I is equal to the set length minus 1. In other words, if it's the last element of the set we're printing out, we'll just print out the element. So we'll say printf %d set at members I, and we'll just print out that last element. Otherwise, if we're not printing out the last element of the set yet, we'll print out the element followed by a comma, just that way we can comma separate the elements of our set. So here we'll say set members I again. And so we just have a loop taking this variable I from 0 up until the length of the set, and we're printing out all the elements of the set. The only thing we're doing a bit special here is the last element of the set, we're not going to have that comma printed out because there's no element after it. For all of the elements preceding it, we are going to print out the comma after them, just that way it looks like a nice comma separated list of the elements in the set. So now we can try the print set function out. So here I'll say print set A, and we'll try to print out the set A, and we should get 5, 6, and 7. So I'll say printf set A, and we should get 5, 6, and 7. And we get 5, 6, and 7 here. Now what I could probably do as well, just so it prints out a little bit nicer, is print a new line after the last element as well, right? Because you can see this program ended with exit code 0 is printing out right after it. So I'll just add a new line to that last element here as well. Save it, run it. And now we get set A contains 5, 6, and 7. Now, one thing we should probably test out is what if I put the same element into the set multiple times? So what if I say insert set A and I try to put in 7 again? If I run this, we still get that set A has 5, 6, and 7. Because what happened was in our insert logic, we detected that that was already a member of the set. And because it was already a member of the set, we didn't insert it. We could throw one more thing into A. We could say insert set A and we'll put in 8. And we could save this and run it. And now we get the set has the members 5, 6, 7, 8. And we could create multiple sets. So we can make set B as well. So that way we can implement some operations like union and intersection that involve 2 sets. So here we'll say set B. So set star set B is equal to init to make a new set. And we'll say insert set B 7. And we'll insert a few more things into B as well. So maybe we'll put in 8, 9, 10. So there's a little bit of overlap with A and B. They both have the elements 7 and 8 in common, but they also have elements that are not in common, like 9 and 10 in B and 5 and 6 in A. So we could also print out the set B. We could say printf set B, and we could print set B, and we'll print out set B just to make sure it's as expected as well. And B contains 7, 8, 9, and 10 as expected, so no surprises here. So now we can start to implement some of these operations that work with 2 sets. We'll start with set union. So here we'll say set star, and we'll call it set union. And this function will accept 2 arguments, a pointer to a set A and a pointer to a set B. And it's going to return a pointer to a new set that it's going to create, which is going to be the union of these 2 sets. So we'll copy and paste this, and we'll provide a definition of the function down here. And the way that we're going to implement this function is we're going to take advantage of the insert operation that we've already implemented, because we know that the union of the sets A and B is just a set that contains all of the elements of A and all of the elements of B. So what we'll do is make a new set. So set star new is equal to init, make a brand new set, and we're going to loop through the members of A and insert all of them into our new set, and then we'll do the same thing with B. So we'll say for int I is equal to 0, I is less than the set A length. So we'll say set A length I++. So loop over all of the members of the set and insert them. So we'll say insert into new set A members at index I. And then we'll copy and paste this because we're going to be doing pretty much the same thing with B, just inserting all the members from B into our new set. So we'll say set B length and set B members at I. And then we're all done. We'll return new, the pointer to this new set we've just created. That's going to have all the members of A and all the members of B. And if there's any overlap between A and B, that's not a problem because our insert function is going to take care of that. The insert function will not insert something into our new set if it's already in there. So we can test out this set union function now. Here we'll say set star set C. We'll make a new set that's equal to set union of set A and set B. And then we'll print out this new set. So we'll say printf A union B, and we'll do print set of this set C. We'll save it and run it, and we should get a new set with all the members of A and B. And that's what we get. We get a set with the members 5, 6, 7, 8, 9, 10, which is exactly the members that are in A and in B. So now we can do set intersection next. So here we'll say set star set intersection. It's also going to take 2 arguments that are going to be 2 sets. So we'll say set A and set B. And we'll copy and paste this. And again, we'll provide a definition down here. And what we'll do now is a bit different. This time, we want to insert something if it's a member of A and a member of B into the new set that results from the set intersection operation. So here we'll say set star new is equal to init, and we'll make our new set again, and we'll return it when we're done our work. And what we'll do is loop over all of the elements in A. And then inside of that loop, we're going to loop over all of the elements in B. And for any element that we find in A that is also in B, we're going to insert that element into our new set. So here we'll say for int I is equal to 0, I is less than the set A length, I++, to loop over all of the elements in A. And now we'll loop over all of the elements in B. So we'll say for int j is equal to 0, j is less than set B length, j++. And now we'll do the check to see if the element is in both sets. So if the element in set A at members index I is equal to the element in set B in the members array at index j, we've found a matching element. And in that case, we want to insert it into the new set we're making. So we'll say insert new set A members I. So we'll save this and we can test this function out now. So here we'll make another set. We'll say set star set D is equal to set intersection set A and set B. And then we'll printf A intersection B. And we'll say print set D. So we'll save this and we'll run it. And for the intersection, we get 7 and 8. And that makes sense because 7 and 8 are the two elements that are shared by both sets. 5, 6, 9, and 10, they're not. So now we've implemented set intersection as well. Next, let's do set difference. So up here, I'll say set star set difference, set star set A, and set star set B. So again, a function that takes in two sets as arguments and returns a new set. And we'll provide a definition of the function down here again. And our program's getting pretty large now. It's kind of cool to make a large program like this. So for set difference, what we want to do is create a new set containing all the elements in A that are not also in B. So we're going to have a more sophisticated loop here that does a check to see if the element of A is in B. So here we'll say set star new is equal to init, and we'll make our new set, and we'll return it down here when we're done. What we'll do is loop over all of the elements of A. So we'll say for int I is equal to 0, I is less than the set A length, I++. And for each element in A, we're going to check to see if it's in B. Only if the element is not in B are we going to insert it into our new set. So we'll say bool in B is equal to false. And we'll start off with the assumption that this element at index I is not in B. But we'll check to see if it is with another loop. So we'll say for int j is equal to 0, j is less than set B length, j++. And if the element in set A at index I is equal to the element in set B at index j of the members array there, we're going to set in B equal to true. Because we've found this element that we're currently looking at with the index variable I in set A, we've found it in B at the index variable j. So if we've gone through all of the elements of B, and it's the case that the element is not in B, then we want to insert it into our new set here. So we'll say insert new set A members I. So take that element that we verified is in A but not in B and insert it into our new set here. And this should complete the set difference operation. So we'll test this out now. So up here, we'll make another set again. We'll say set star set E is equal to set difference of set A and set B. And then we'll do a printf of this. We'll say printf A minus B and we'll print out this set E where we've stored the result. So we'll save this and run it. Let's see what we get here. We get 5 and 6. And that makes sense because 5 and 6 are the elements of A, the members of A, that are not also members of B. Because 7 and 8 are members of B. Now we can try B minus A. So here we'll say set star set F is equal to set difference set B set A. And we'll do printf. And I'm going to say here F is equal to B minus A because I'm going to use F again in a little bit. And then I'll say print set F. And let's see what we get here. Oh, I forgot a lowercase f there. So I'll save this, run it. And we get that B minus A is 9 and 10. And again, that makes sense because 9 and 10 are the members of B that are not also members of A like 7 and 8 are. So now we've implemented the difference operator as well. Next, let's try to implement the subset operation to see if one set is a subset of another set. So here we'll say bool is subset, and we'll say set star set A, set star set B. And we're going to check to see if A is a subset of B with this function. So again, we'll provide a definition of the function down here. And what we're going to do is something very similar to this, really. We're going to be checking all of the members of A to see if they're in B. If we ever find a member of A that is not in B, we know that A is not a subset of B. If we get through all of the members of A and none of them were not found in B, then we can say that A is a subset of B. So here we'll say for int I is equal to 0, I is less than the set A length, I++. So go over all of the elements of A, and we'll say bool in B is equal to false. And again, we'll search for the element in B. So we'll say for int j is equal to 0, j is less than the set B length, j++. And we'll say if set A members at I is equal to set B members at I, we're going to set in B equal to true. So at this point, we've verified that at least the member at index I in set A is in set B, if in B is true. If it's not the case that in B is true, then we found an element in A that is not in B. And at that point, A is not a subset of B, and we can return false. If we get through all of the elements of A, and they've all been found to be in B, we can return true, because we know that A is a subset of B at that point. So again, we can test this function out now. So we'll go all the way up here again, and we'll do some tests. We'll say if is subset set A set B. So check if A is a subset of B. Then printf A is a subset of B. Otherwise, we'll printf that A is not a subset of B. So A is not a subset of B. And we'll do a check here. And in this case, we expect that A is not a subset of B, right? Because we have 5, 6, 7, 8, and 7, 8, 9, 10, and that's not a subset. Because there's elements of A, like 5 and 6, that are not in B. So we'd say that A is not a subset of B, and that is what we expect. Next, let's try a case where we do have a subset. So here we'll say if is subset set F set B, then printf F is a subset of B. Otherwise, we'll printf that F is not a subset of B. So we'll try this. And here we get a bug because F is a subset of B. Let's go look at our code again and figure it out. So if we scroll down to our function, I'm checking if set A members I is equal to set B members I. So that's the problem, right? We want to check for index j because it's this loop using the counter variable j that's going through all the members of B. So we have to have j there instead of I. So we'll save this and we'll go up here and we'll give it another test. And now we get f is a subset of B, and that's what we expect. This is why it's important we actually test our code to make sure we actually wrote it correctly. So now we'll try set equality next. So up here we'll say bool set equality. It's also going to accept two sets as arguments. And again, we'll provide a definition of the function down here. Now this function is going to look a lot like isSubset, which looked a lot like our difference function. So I'm actually going to copy and paste the subset code here because it's going to look so similar that I don't really want to write it all over again. So here, what I'm going to say is if the set A length doesn't equal the set B length, then we're going to return false. Because if the lengths of the sets aren't equal, then there's no way that they can be equal, right? If set A does not have the same number of elements as set B, there's no way they can be equal. But if the sets do have the same length, then if we just loop through all of the elements of A and find that they're all in B, then we've shown that they're equal because they've got the same number of elements and we've shown that they're all the same elements. Now I just copied and pasted this code. But what I could also do is this. I could say return, and we'll call the isSubset function. So we'll say return isSubset set A set B. Just so that way we don't have the same logic identically in our code again. Because, this is all we really need. If we determine that the sets have the same length, then if one set is a subset of the other, they must be equal. So we'll call this function and test it out as well. So up here, we'll give it a test again. We'll say if set equality set F set B, then we'll printf F is equal to B. Otherwise, we'll printf that F is not equal to B. So we'll save this and we'll run it. And we get that F is not equal to B. And that makes sense because F has the elements 9 and 10 in it, whereas B has the elements 7, 8, 9, and 10 in it. So it does make sense that they're not equal. Let's try a case where we do have equal sets. So I'll make another set here, G. I'll say set star set G is equal to init. And we'll insert 9 and 10 into G. So we'll say set G, insert 9, insert into set G 10. And then we'll print out G just to verify what it looks like. So we'll say printf G, and we'll call print set to output our set G. And it's got 9 and 10 in it. So let's see if set G is equal to set F. So we'll say set F, set G, and we'll do a printf here. We'll say F is equal to G if the function returns true. Otherwise, we'll printf that F is not equal to G. So we'll save this here now and run it. And we get that F is equal to G. And that makes sense because set F has the elements 9 and 10 in it. Set G has the elements 9 and 10 in it. So they are equal. So we could just keep on going forever here, implementing more and more set operations. I'm going to implement one more that's going to simplify some of the functions and operations we've already created. I'm going to make a function to check whether an element is a member of a set or not. So here I'll say bool is member set star set and then int value. And what we're going to check is whether this value is a member of the set or not. So we'll copy and paste this, and we'll provide a definition of the function down here. And all we're going to do is loop through the members of the set and check to see whether the value is in there. So we'll say for int I is equal to 0, I is less than the set length, I++, and we'll say if the set member at index I in the members array is equal to the value, we found it in the set. And we can return true. If we get to the end of the members in the set and we haven't found the value, then it's not in there. And we can return false. So we can use this function to check to see if a value is in a set. So we can give it a quick test. So up here, we'll do a check. We'll say if is member set f, and we'll check for the value 9. Then printf 9 is in set f. Otherwise, we'll printf that 9 is not in set f. So we'll save this here and run it. And we get that 9 is in set f. We could do another test for something that is not in set f, because set f has 9 and 10 in it. So for example, we could check for maybe 11, because 11 is not in f. So we'll try 11 here now. And we'll save this and run it. And we'll just fix this to say 11 instead of 9. But we save it and run it, and we get that 11 is not in set f as expected. So now that we have this isMember function, we could actually use it to simplify some of the other functions we've already written, to refactor our code. So a lot of these operations that we've implemented have this check for membership. Like right here in the insert function, we're checking to see if this potential member is a member of the set already here. And it's basically the same code that we just implemented in that function. So what we could say here is if not isMember set member. And we'll just get rid of this logic here. That's basically just checking to see if this value is in this set. We can keep doing this for other functions as well. So set union is okay. With set intersection here, there is an opportunity to simplify our code. Because what we're doing right now is going through all of the elements of A and all of the elements of B. And if we find the same element in A and B, then we insert it into the new set. What we could do instead is just go through all of the elements in one set. Let's say set A. And we'll use our isMember function to check to see if that element is in B. And if it is, then we can insert it. So here we'll say if isMember in set B, this element of the set A set, then we're going to insert it into our new set. And so we just kind of refactored and simplified our function a bit here to take advantage of our isMember function. So same here with set difference. We again have this check to basically just see if something from set A is in set B. So what we could do is, again, just simplify this. Delete all this, and we'll just call the isMember function. So we'll say if not isMember set B, this element that we're looking at in set A at index I, then insert it into the new set. So again, just refactoring it to take advantage of our isMember function. And very similar again with the isSubset function. We're basically doing the exact same thing. We can really just copy this here. So we'll say if not is a member of set B, this element in set A, we can return false because we know that means that A is not a subset of B at that point. And that should really be it in terms of refactoring. So we'll go up here and we'll test our code to make sure it's all functioning correctly. And we get a build failed. Let's see where we got the error. Looks like a bracket issue. Yep, I forgot a bracket. So we'll save it, run it. Build succeeded this time. That's always good. Let's go through and make sure everything is still working. So set A is empty. That's true at that point. Set A is this, set B is this. The union looks okay. The intersection looks okay. The difference operator seems to be working okay. It's true that A is not a subset of B. It's true that F is a subset of B. F is not equal to B though, right? Because B says 7, 8, 9, 10 in it, and F has 9 and 10 in it. Set G is 9 and 10. F is equal to G because 9 and 10 is equal to 9 and 10. 9 is in set F and 11 is not in set F. So our code is working okay. And so like I said, we could just keep on going forever with more and more set operations. And as we implement more operations, there may be opportunities to continue to refactor our code to use other operations we've defined. I went over an example of doing that just now. So I think we'll just leave it here at this point. Hopefully this has been a helpful introduction to defining and using a set data structure in C. Check out portfoliocourses.com, where we'll help you build a portfolio that will impress employers, including courses to help you develop C programming projects.